Next, we have the presentation on cutting-edge advancements in wind turbine technology. We have two presenters. I invite them here on the dais. Mr. Samar Barua and Ms. Kavitha M of Senvion Wind Technology Pvt. Limited.
Good afternoon, everybody. My name is Kavitha Matangi, and I am heading the research and development wing of Senvion. We are based out of Bangalore. Today, we'll be talking about the cutting-edge advancements in wind turbine performance, and we'll walk you through to show how we are doing it. Let me start with the vision. What is our vision at Senvion? At Senvion, we want to make wind work for us and generate energy and power by using wind energy. And to achieve that, we want to make India a future country where our base load of energy is coming from wind, mainly focused on wind energy. And to achieve that, we have been relentlessly harnessing wind energy in India. To name a few facts, Senvion is the fastest growing wind energy organization in India. I'm very proud and happy to say that we have doubled our revenues in 1 year, 2022-23. It's like a huge achievement in Indian market for the size of an organization like Senvion. How are we currently operating? We have an R&D center with more than 200 engineers based out of Bangalore. We are closely working with our partner organization, RE Technologies, which is in Hamburg. And we have making all our components, blades, towers, everything in India. Research, development, design, technology evolution, including our control systems, is homegrown, homemade and manufactured in India. 85% of our components are made in India in our plants. We are manufacturing mostly from 3 states, Karnataka, Maharashtra and Tamil Nadu. We have our headquarters, our sales and marketing operations held from Mumbai in Maharashtra. So I would like to speak a little bit about our business model. We are a very flexible organization and we are partnering with best of the world organizations in achieving our mission. We are working on world-class technologies with best SCADA and control systems to make our predictive analytics, robust designs, at the same time world-class technology made in India, and we are very agile organization, and this is making our partnering with others, also having control on our critical products and services. We are existing throughout the life cycle of the product, and we have a wonderful operations and commissioning setup which is based and working out of India. Today, I would like to set the stage. What main focus is about is in Indian market, we have very harsh temperature, dust, humidity, and environment conditions which are posing a major challenge to us. And we are also looking at sustainability and safety aspects in wind turbines. So I would hand over to my colleague Samar, who would walk us through how in Senvion, using state-of-the-art software and SCADA systems, we are making predictive analytics, making our product more robust, safe, and future-ready. Thank you.
Maybe I will start with the new platform that we are building, right? And I think we launched it last month in the Hamburg fair. So I will be talking about how we are going about it, right? So we'll start with the components, and then I will also come to how we are doing from the software side of it. So we start from the blades, right? So the blades, this time it's a bigger rotor. So what we are doing is that we are going with what we call as the single blade installation, right? So it has been done before, but I think we in our 2XM platform, the existing platform, we are not doing it. So this will be something which is new for us. Right? And then what we are also doing is that we are using advanced materials, which allows us to have a high stiffness blade, still maintaining the low weight of it. Lightning system. We have one of the best-in-class lightning system with us, and uh, it's like we don't have just at the edge of the blade or at the outer board, right? But we have receptors even built in the blade, in the span of the blade. Coming to the mechanical part of it, what we are doing there. We have upgraded our personal safety. Basically, what it means is that we have added anchor points where we thought we should have. We have now evacuation from the hub, which is again the first time that we are doing in our platform. Anyways, it was already there, always from the back side, but hub is a new thing that we are adding. Replaceability and retrofit. We are now able to do most of our retrofitting and replaceability from the up tower. Means we don't have to say bring cranes and do the replaceability or say replace components. Most of the components, of course, not everything can be. We can do it up tower, but most of the components that we think we can do, we are doing it. Pitch bearing. We are using advanced pitch bearing system, which enables us to use advanced controls, which then alleviates the load on the other components. Coming to the other components, towers, what we are doing there. The internals, what we are doing is that we are simplifying how the internals are. Like earlier when we were talking about, say, doing any repairs on the internals, it was not reachable. So what we have done now is that it is now close to the ladder that we have, so that we can just do it with safety. I think that is the important point here. With longer towers, we of course cannot make these any more stiff, right? So they have to be soft. But then with the soft towers, how do we deal with it? So we have the control system which enables us to make soft towers but still not get into the oscillation issues that we generally see with the towers. Lattice tower, I will not talk much about it because it is not coming in our prototype, the first prototype that we are launching. But then we are also working on a new, what we call as the NTI, right? Where we are also looking into lattice tower, which goes beyond 150 meter height, basically. Electricals, what we have done, we have now upgraded the electrical systems to a 950 volt system, which then improves our electrical losses. Cooling system, again, means I think this is probably one of the best cooling systems that we are making, which can handle the high ambient temperatures that we see in the Indian conditions. And we are fully committed to meeting all the regulations that we will have, or whenever it comes. Again, means what is not mentioned here, but I will also point out, is the grid compliance. We are working towards being fully grid compliant, integrating it with our grid, and then whatever regulations we have, say like the LVRT, HVRTs, etc., we will be fully committed to it, and we'll fulfill them. Okay, maybe I will. I have still some time remaining, so I will. So what we have seen till now is the hardware part of it, right? How do we do from the next, means what you don't see, but what actually make the turbine operate, right? And also how do we monitor our wind turbines? So I will come to that now. So these are the three verticals, and this is the team that I lead. So I'm a bit more passionate about it. But anyways, yeah, so these are the three verticals that I'm talking about. Loads, one team is loads, the other is controls, and then the SCADA. And then these three verticals come together to build something, or we are trying to build something which can then give you a bit more push towards the technology, right? So what I will do, I will take one vertical at a time. So what you're seeing right now on the writing, I will not go through the writing, but it's on the loads, right? So in the loads, what we are doing, loads is something, and people who do loads, they know that it's like we are simulating the complete system here, right? So you can imagine that the model will be pretty complicated, means with lot of files, lot of data, and it is very error prone. Means a small mistake by the engineer can make the complete simulation go haywire. So we are building a tool that handles it automatically, right? Means it builds the model for you. You have to just tell that what configuration you want to use. It will build the model. It will do the pre-processing and post-processing and give you the loads that you can then share to the components team or the components people, right? So that is one thing. Then we are also looking into how do we build the database for site evaluations. So you get 100 turbines and you get the loads for the 100 turbines maybe in 5 minutes time, right? Then stability is now a big issue because now the blades are becoming longer, slender. Same with the tower. How do you handle the frequencies, right? And how do you handle the oscillations that you see? And you can get a lot of issues with the blades that we have already seen in the rotors going beyond 160 meters. So we are looking into how do we use high fidelity modeling to analyze our the longer blades basically. Then the most important thing, how do you trade off between the loads and the operation of the turbine, right? Means you have to, you cannot push the wind turbine to a limit where you break it, but you cannot also be very conservative and then let go of the life of the component. So how do we make that trade-off? So these are the things that the loads and performance team does. Maybe I will move a bit quicker here. Already see it is over time. Controls again a very important aspect, right? Without control, the machine is just standing there. So what we are doing in that control means we are building features which will optimize the operation of the turbine in the partial load region, right? Means that's where once you are rated, right? You don't do much about it. But what you are doing in the partial load region, that's where we are working on. Then we are also looking into how can we auto-tune all the parameters that we have so that we keep always operating on the optimal, right? Braking procedures, we know that it's the braking that kills the turbine, that kills the life of the turbine. How can we make it softer? That is another topic that we are looking into. Then, of course, another thing is the modular control, right? Means we are building now a control, and I have to say that we are building a new control altogether now. And that control we are building as a modular control. What it means is that every feature is a module. And then you can, anytime, if you feel that you have better control feature that can control your turbine better, you pull that out and put in the new feature. So that is what we are doing. Of course, the future vision is to get into the what we call as the MBPC, right? The model-based predictive controls. Again, means when I talk about future, it's not like 5 years down the line. I'm talking about 1 year down the line, right? Lastly, the SCADA system, what we are doing there. So SCADA system, again, it's the face of the turbine, right? That's what the customer sees. And then what we are doing there, we are looking into how do we capture the high frequency data, right? And then monitor at the farm level as well as at the fleet level, right? Farm level for the customers, fleet level for us to understand how our wind turbines are actually performing in the field. Scalability means our fleet is growing. We are getting into new platforms. Can the current SCADA system handle it? That is what we have to analyze, and that is what we are doing. And we are making it such that we are making the architecture such that we enable the scalability of it, right? Means so it can be scaled to the next level whenever we want to. Generation of reports, very important, right? Means auto generation means that's the key. Means we have to generate our reports automatically, right? The system has to generate it for you. And then it should be easy to customize it. Cyber security, again, a very important topic. We are working towards that, of course, with strong encryption and strong access control. So that's the vision here. Again, means the future, what we are looking into, say 1 year down the line, a single setup, a single system that, right from people in the field, service people, to people in the, means people who are sitting in our office, they have a single application that can be used to monitor and control a single turbine. You can monitor at the farm level, can be given to the customer as well. And then centrally in our office, we look into at the fleet level, right? So, but then the key is, again, the key here is that we are looking into how do we do all this from a single app, right? So that we don't confuse people with showing them different windows. Predictive maintenance, I think, and the AI implementation, I think these are two important things that we are again started looking into. Predictive maintenance, yeah, I don't have to talk much about it. AI, I think AI, at least in my understanding, we are still very new in wind turbine, I would say, when it comes to AI. So we are looking into ways how we can use the AI that has, say, for the past 2-3 years, we have seen the growth of AI to a huge extent. How do we bring it into our SCADA system and, increase the operation, means to optimize the operation, rather I should use the word optimize the operation of our wind turbine. So yeah, I think I have taken a lot more time, but hopefully it is okay because we are breaking for lunch. So thank you.